Hello बच्चों, let's read the question. So the question says a neutron with kinetic energy K is equal to 10 mega electron volt activates an endoergic nuclear reaction N plus carbon gives beryllium plus alpha particle. Initially, carbon was at rest. The threshold energy of this reaction is 6.5 mega electron volt. Find the kinetic energy of the alpha particle in mega electron volt going at right angle to the direction of the incoming neutron. So to understand the question better, we must first draw a diagram. So we have a neutron here which collides with a carbon atom to give alpha particles at 90 degree. Let their mass be m3 and velocity be v3 and kinetic energy be k3, and beryllium at certain angle from horizontal, let it be theta. This is beryllium particle, let its mass be m4, its velocity be v4 and kinetic energy be k4. The mass of carbon atom be m2, which are all known to us, and velocity is 0 and kinetic energy be k2. Mass of neutron be m1, its velocity be v1 and kinetic energy be k. Now let us first revise the key concepts behind this question. So what are the key concepts? So the first key concept behind this question is conservation of energy. Why is conservation of energy applicable here? Because it is a completely elastic collision. And second is conservation of linear momentum. Why is the conservation of linear momentum applicable here? Because there is no net external force. Now keeping these in mind, let's dive deep further into our solution. So we apply first conservation of energy in our question. So we have m1c square plus m2c square plus k1 plus k2, which is 0 because kinetic energy of carbon is initially 0. It must be equal to m3c square plus m4c square plus k3 plus k4. This is by conservation of energy. Now from here, let's suppose these all values be q. So let us put them q. These are constants and everything we know. Let the constant be q plus k1, q plus k1 is equal to k3 plus k4. Now we can find q here. So q must be equal to the threshold energy, okay, with negative sign because threshold energy itself negative, and E3 upon 1 minus m1 over m2. Okay, so this is our q. So let us put it here. No, this is not minus, this must be plus. Okay, solving these we get it. So this gives us the value is equal to minus 6.17, which is given, and this is equal to 1 plus 1 by 12, which gives us 12 by 13 into minus 6.17. Hence it is equal to minus 5.69 mega electron volt. Okay, so this is our value of q. Let us keep it with us and let us mark it as equation 1. So find K3 in this equation, we have Q1. Now let us find further a relation using conservation of momentum. So applying conservation of momentum. So first on x-axis. So on x-axis, in diagram we can see that momentum of neutron must be there and the x component of beryllium must be there. So its momentum we can write root 2 mk. So it must be equal to m1 k1 for neutron. It must be equal to root 2 m4 k4 into cos theta, because it is cos component. So here root 2 gets cancelled, and squaring both sides we get m1 k1. It must be equal to m4 k4 cos square theta. Now let us first keep in mind that we are going to make a relation between k4, k1 and k3. We are trying to find it by conservation of momentum. Let's apply it in y-axis. So in y-axis we get root 2 m3 k3. It must be equal to root 2 m4 k4 times sin theta, because this time we are applying it vertically. So momentum of m3, momentum of alpha particle and sign component of beryllium. So again root 2 gets cancelled, and squaring both sides we get m3 k3 is equal to m4 k4 sine square theta. Now let it be equation 2 and let it be equation 3. So adding 2 and 3 we get m1 k1 plus m3 k3. It must be equal to m4 k4. From here we get the value of k4 is equal to m1 upon m4 times k1 plus m3 upon m4 times k3. So putting this value, let it be 4. So putting this value in equation 1 we have, and putting value of q. So value of q is minus 5.69 we have find out, minus 5.69, and k plus k1 plus is equal to, sorry, correct it, is equal to k3 plus m1 upon m4 k1 plus m3 upon m4 k3. Hence it is solving it, we get for k3 solving it, we have minus 5.69 plus 1 minus m1 upon m4 times k1. It must be equal to 1 plus m3 upon m4 times k3. So solving for k3, we have k3 is equal to minus 5.69 plus 1 minus m1 and m4. We have value of m1 and m4 which are 1 upon 9, and value of k1 is given to us as 10 upon, we have 1 minus 4 by 9. Now solving it, we get 9 over 13 times minus 5.69 plus 8.89. So we get our final answer, K3 is equal to 2.21 mega electron volt, and this is our final answer. I hope you understood it well. Thank you.